Hi everyone, welcome to our Data Science, Machine Learning and AI course, your first step towards mastering the skills to become an artificial intelligence AI expert. Our current module is all about Python fundamentals. Check out the full playlist in the description for everything we have covered so far and hit subscribe to stay updated with new lessons and future modules. Today we are going to learn about very important concept in Python and in general in all programming languages called object oriented programming. What is object oriented programming and what is the importance of this methodology and how we can actually use it in our own programming examples? I'm going to show you all that in this tutorial. And firstly, we will actually take an example of a real world use case, and then move towards understanding the core functionality of object oriented programming and different objects, building blocks, and also some key principles in this. And then we will have some examples in Python that we will try to apply all these key principles over there to have a clear understanding for all of you. So please, if you want to learn about object oriented programming and you want to know the key functionalities and principles and want to have a very core concept of this object oriented programming, watch this video till the end so that you can learn this concept and start implementing it in the coding examples or the projects that you will be building on in future. So please, let's start diving into object oriented programming. Before going into that, we are going to take an example of a robot manufacturing example. So what do we see in this example? That we have a manufacturing process, so we call it manufacturing. And then what is being manufactured? Robots are being manufactured here, and the robots manufacturer actually manufactures robots with some attributes, and each robot has a ID that is specified. So ID can be an identification number for each robot that is used to actually identify the robot manufactured by the robot manufacturer. And type can be the purpose, and there can be robots for household use, there can be robots for gardening, there can be robots for cleaning dishes, there can be robots for taking care of pets, there can be robots for just monitoring the entrance and of the home and all other things. So that can be the type of the robot or as an attribute as well. And the functionality that robot will be supporting, like there will be some built-in functionality from the robot, like for example, cleaning floor is a functionality of the robot that comes with it. Now robot manufacturer will create a lot of robots with different functionalities that will be built into them, and with some attributes that will be type, ID, and so on. So this robot manufacturer is doing what is constructing or creating robots, and these robots actually have these attributes, and each robot can have different attributes based on the type of the robot it is. Like we have an example with ID 123 and a household type of a robot, and then this robot has a behavior of object that I have mentioned here. I have intentionally mentioned this object here, word object here. Why? Because when we go to the next step where we are going to learn about the attributes and the types of object oriented programming, it is very important that you understand what is object. So the same way we have robot here, robot is an object, and the behavior of the robot is the cleaning floor. That is actually the behavior that is built in. Remember that robot manufacturer adds these built-in functions to the robots, and every robot that it is manufacturing, is constructing, is actually having this built-in function, cleaning floor. This concept as an analogy is very important, because when we go to the next slide and we are going to discuss about object oriented programming, this will be very helpful. And also remember, when the robot manufacturer is manufacturing these robots with these IDs and types, these attributes, you see attributes in the each robot as well. So each robot can have different IDs, and they can have a different type as well. So they also hold, the robots also hold these attributes. Now going back to the next example, which is the overview of object oriented programming. As you can see previously, the place where we had manufacturing, in the next slide I actually have object oriented programming here. So object oriented programming as an analogy is doing the same thing as it is being done in manufacturing, and then class is a manufacturer that constructs objects. So in the similar way, we saw that robot manufacturer was constructing robots. A class in object oriented programming is constructing objects. Okay, so this is clear. So the example is that the similar way robot manufacturer was constructing those robots, in object oriented programming, class is the manufacturer, it is constructing the objects, which in the previous example we saw as robots. So each class will have some attributes that you will provide. For example, in the previous example, when we wanted to create a robot, we specify the type to the manufacturer that create a household type of robot, and that is what will be created. In the similar way, here in the class, we specify some attributes, and the class will construct an object based on these attributes, and these attributes will be actually held by this object as well, and this object will be called instance of the class. So remember, any object that is constructed or created or initialized by the class is called instance of the class, that it is being constructed by the class. When we, in the similar way in the previous example, we can say that a robot manufactured by robot manufacturer ABC. So this manufacturer can have a name ABC, and then we can actually go back to the overview, and then class is creating or constructing these objects. These objects are called instance of the classes, and then they hold these attributes and they have behaviors. Similarly, in our robot manufacturing example, the behavior of the robot was the built-in function that the robot manufacturer was adding to the objects. Similarly, in this case, when we have objects actually created by the class, these objects will hold these attributes which were used to create these objects. To define this object, each object will have different attributes based on its construction, and then it will hold the behavior that is actually assigned to it by this class based on the methods or functions that are built in. In the example that we saw earlier, where we have this cleaning floor or as a feature, as a function or method built in by the robot manufacturer, here we can have different functions or methods built in class that will be the methods of the object as well, because object is an instance of the class. So this was a simple example I created just to give you an idea what are objects, what are classes. A class constructs the objects, and objects holds attributes and methods, behaviors, which in other words we call, and they are actually defined by the class. Now there are actually multiple key principles that are very important for object oriented programming: encapsulation, abstraction, inheritance, and polymorphism. So in our coding example, we will first look at the definition of class, how to define a class in Python. Then we will step by step go into all of these key principles, which are encapsulation, where we restrict direct access to an object's data; abstraction, where we hide the complex implementation details and expose only the essential features; inheritance, where we actually create a subclass from a superclass; and then polymorphism, which allows us to redefining methods for subclasses. So these are the key principles that we will actually have hands-on examples to do, and you will have all these learning experience for all these key principles, and this can level up your programming skills. If you have a very good concept of object oriented programming, that can take you one step ahead from other beginners that are already trying to learn but have not even learn this concept, and then you can start writing your own modules and packages, libraries based on this initial concept that you will learn. So in the next step, we will be diving into the coding examples, and then we will actually practice all these things one by one. So I'll see you in the coding example just now. So now in this coding example, we will learn about the class definition for object-oriented programming, and then other key principles that we discussed in our uh, presentation. So let's dive into the coding examples. So first, we are going to define a class for a student. So in order to define a class for object-oriented programming, we use a keyword named as class, and then we need to give the name to our class. So our class can have any name that we want. It should not be a reserved word, and then it should have first letter alphabet as capital as a convention. So the class that we are going to write is for student, and then we need to put colon at the end. So this is how we have defined a class named student. And then after that, we need to define initialization method. Remember, when we discussed in our example that a class constructs an object or initializes an object. So we need to write the constructor function, or in other words, initializer function that will actually initialize the class. So we are seeing some suggestions here how to do that, but I'm going to type it myself just to show you. So the initialization or the constructor method is actually written as underscore underscore init underscore underscore. So this is how we define that initialize function, and then we type self. Now why we type this self here? Remember, self is the class itself. This student class is self itself. So whenever inside the class you want to call any feature or any attribute or method of this student class, you will use self as itself that I'm talking about. Like student class is talking about itself, so that is why remember that you will be using self, and I will show you how. And now for the student, we want to set some attributes to create a student object, and it can be name and it can be grade. Okay, and then at the end, again, you know that whenever we define a function, we have to add a colon at the end. Now once we have actually written the definition of the constructor function or the initialize function for the class, which is def init underscore underscore init underscore underscore, and then self, remember to add this self here, word here, and then after that we have these two attributes or parameters of the function, name and grade. Now how it will work? So the convention is that you need to set these attributes if you really want to access them from this object. So why are we actually creating this class? So take an example that we are in the administration of a college, and the college wants to automate the admission forms of the students and the information of the students, and they want to create this information every time when a new student enrolls, or they want to actually integrate this information for the results of the students. For example, uh, exams just finished and we want to write a student class to actually create the result for each student, and then we want to save it at the end of the month. We want to show this result. So this student class will be creating object student for every student, adding their name and adding their grades, and then at the end we can just print the grades for all the students and display them on the notice board or on the website of the college as well. That is the example that we are actually considering. Now if we have, if we want to set the attribute, we will call it self dot name. Remember, I said whenever you use the word self, you are referring to the class itself, and then we are setting an attribute name of this class, self dot name equal name, and in the similar way we will do it for the grade as well. Now we have actually completed the initialization function for this class, where we have the name and grade attributes passed, and we are setting them self dot name equal name, self dot grade equal grade. Now we want to write a function where we want to return the grade actually. So that will be a function that we will call here. We say define get grade, and then get grade is a function or a method for this class that we are defining, and it will be using self as an argument. Why? Because this self will be allow this function to, or this method to, access these attributes. Now once we pass this self as an argument, and remember self is compulsory for the attribute of this class, and then if you want to pass some additional arguments to this method as method, you can also do that as well. You just need to specify a comma and then add those parameters as well, but right now we don't need that. Now we want to actually get the grade, and what we will do, we will just return self dot grade. That's it. This is the example of our student class. Now I can run it. So we have executed it. Now let's create an object. So we are going to create an object of student. So that student can be student 1, and I will say student 1 is I will call the student class. So my student class name is student with capital S. I defined it. Now if when I want to specify or initialize the new student object, I need to provide the parameters in parentheses. So I have written the student class name, then I have these parentheses, and inside parentheses I need to first specify the name and then specify the grade. So first I will specify the name of the student is Abdul, and then the grade of the student is A. Now I will actually run this cell. After this, what I will do, I will actually write a print statement to get the grade of this student. Print student 1 dot get grade. Let's run it. Now remember that you have been seeing this thing happening over a lot of things in the past as well. Remember when we were actually looking at different methods for dictionary and different methods for lists, tuples, and many other data types in Python, we were always calling their methods using this dot. If you remember, if you have watched the previous videos, I highly recommend that you check the uh, playlist in the description and watch all those videos. And if you want to learn more about that, coming back to this, we are able to access the method get grade, which is for this student 1. Now this was defined here. Now let's go ahead and define another student. What I will do this time, I will define student 2, and this student 2 I will define it in the same way, student class name, and yeah, let it can be uh, Alice. And now Alice has a grade A plus, for example, and I can run it. Now I can just copy paste this one from here to just quickly write it here, and I will just change student 1 to student 2. Now this time you will see that it will return us the grade of Alice, which is A plus. So now you have seen this example that you can define a class, and it gives us this advantage that we can be creating the class of multiple students to store their information as well. Like instead of just having name and grade, we can have the roll numbers, we can have the session where they when they joined, if they have any pending dues, all different details we can include in this student class. So that was an example of class definition where we actually write a constructor function and initialization function where we define all the attributes, set those attributes for the class, and then we write some methods for the class which can then be accessed by the objects, and objects are instance of the class. So student 1 is instance of class student, student 2 is instance of class student as well, and these are objects. Student 1 and student 2 are objects, and they are called instances of class student. Now this was very basic initial concept of class definition. Now let's dive into the encapsulation concept. In our presentation, we have seen that encapsulation is one of the important principles of object-oriented programming, and what it does, it actually restricts direct access to an object's data. So how we can actually do that? So For this thing, we are actually going to just go ahead and copy paste what we have written previously. So I will copy this class definition and we will build on top of this the encapsulation example. So here I'm going to actually copy paste this example. Now what encapsulation does is that it restricts access to the variable or to the attributes, and you can only access them via some methods. So if you don't want mistakenly the grades to be set by anyone else or by any other way, so you can restrict them by encapsulation, and only specific method call can change the grades. So that can be a administrator access or any other thing that we want to define in our code later as well, just to make sure that it's not easy or it's restricted to actually change the grade without going through a specific method. So in order to make any attribute of the class as a private attribute or that is not accessible to directly, we need to actually define it as underscore underscore. So by adding these two underscores here after the self, we have made this a private attribute, and it will not be accessible directly. And when we say define get grade function, it will also call this same underscore. So first example that I'm gonna do, I'm not going to write anything else, but I will run this class and I will copy paste our previous code as it is. See, now what I have done, I have actually created this instance again for the class. Student1 is actually an instance of class student. And if I want to access this attribute underscore underscore grade from here, I will get an error. Student1 dot underscore underscore grade. Let's print this one actually. Let's run this one. Will throw an error actually because it does not see it as an attribute. But okay, now let's try to do something different. If we try to access the get grade method, let's see. Now the get grade method is actually returning us the private attribute, but if we try to access this one in the like just directly, we cannot. Okay, now let's see if we were able to do that previously. We have the other example where we have this student 2 already defined, and we can just check with this our previous example that previously when we were not setting the grade as a private attribute, were we able to access it? And let's just quickly check student print student 2, and we will just print the grade of student 2. See, when we did not set it as a private attribute by adding two underscores, we were actually able to access it. But now when we have added these two underscores, it has totally made it private. You cannot access it externally, only via the methods that we have defined inside the class. Now in order to actually change this value, you need to add a set method as well. So what we can just do, we can define a set method here. Define set grade, and what we do, we want to change the grade. For example, if I'm a teacher and I want to change the grade, I will just specify it in this way, that set grade is a method that you can call. Self will be the first parameter always whenever you are writing a method for a class. There are some special cases where you don't need this self, but if you want to use the attributes of the class, you need to specify self, and any additional parameter that you want to use, you need to specify that one here. So I'm specifying grade here, and over here what we will do, self dot underscore underscore grade equal grade, and this will override the grade. Now let's run this class again. We will run this student1 instance again to create a object, and now we will check the grade first. So now you see the grade is A. I want to change the grade. What I will do, I will say student1 dot set grade. Now I will call the method set grade that we have defined, and I want to change its grade to B, for example. I will run this cell. Now I have actually changed the grade of the student, but I have not checked whether it has changed or not. I will run this print statement again. I will copy paste it. Let's run it again. Now you can see the grade of the student has changed. So that is how you can actually perform encapsulation, that you can set some attributes to be private and not accessible directly, but they can only be accessed via some methods, and then they can be changed or retrieved. That was an example for encapsulation. Now, coming back to another very important key principle, abstraction. Why abstraction is important? Abstraction is actually required to hide some complex implementation details and keep some of the infrastructure of the code, or like the structure of the code consistent across different people. So if many people are actually writing different classes, if you define an abstract class in the beginning, the abstract classes and methods enforce that certain methods must be defined by subclasses, creating a consistent interface. So this will just create a consistent interface of the code, and you initially you can just define the abstraction that this many functions can be defined for this object, and everyone can take that idea to have this consistent interface of writing different classes. So let's take an example. So in our previous example, we learned about encapsulation. If we want to create an abstract class, uh, first I want to show you one small concept about uh, modules. What are actually modules? And I'm just going to do that here to show something. Before I import something, I will just show you a basic idea, a very basic idea, and it is here. So this is the place where we can create any file. So I'm just going to click here to create a new file, and I will name it student.py. Remember, the Jupyter notebooks that we use, they have an extension of ipynb, and the Python scripts that we use in our programming, they have the extension of .py, and mainly you will be working a lot with .py files as well, because you will test your code in Jupyter notebooks, but finally you will package them into some scripts and make them into a module or a package, and that can be used by someone else as well. So that is very important. So I'm creating a student.py file here. I have created. Now let me open this one, and I'm going to actually show you how different modules are created and how you actually import different modules in your code. Now right now we have the student.py, which will work as a module, and we will actually add some code into this module as well. So once we open this one, we can actually write our code in it. And so let's just write our code inside this one. So this encapsulation example, I'm just going to copy it and paste it here. You can see that I have added this class student here. Now, this is a module that I just created. Student.py is a module that I created, and it is already present here in my directory. So I can just go back, close this one. I want to show you an example how I can even import this one. How I can import it? I can just come here and say import. Okay, now there are two things that you can do. You can import student as it is, which is the script module that I have written, and I can run it. Now it has completed successfully, and student has some attribute, some classes inside it in this module. So this student.py, if I just do dir, it will tell me what is there. So it is defining me, telling me that there is a class named student with a capital S inside this student that I have defined. So this .py file is a module, and inside this module I have a class with capital S student that I can actually import. Now, one thing that you can do, you can access this student class either by importing the complete module like import student, and that will be like this. And now if I want to create the example student 1, I will just have to say student dot capital S student. So student with small s is the name of my module, which is .py file, and then student with capital S is the name of the class which I have created and which is present inside this module. And now what I need to define here, I need to define the name, which I will define again as Abdul, and then I can define the grade and run it. So this will run successfully. That is one way to actually create this instance, by importing the complete module. Sometimes you don't need actually everything in the module. So what you can actually do, you can just import some specific things. So you can say, rather than importing the complete module student, you can import from student, which means that from the module student, import the class named student, which is with capital S, and run this, and this will import that. Now when you import it in this way, I'll copy paste this one, and now you will not have to specify this student module anymore. You can run it easily like this. So this was some functionality regarding the import, and how you can import a module, or how you can import some classes from a module. That was very important before we dive into the abstraction here. Now when we are going into this abstraction, we will actually import some modules. You don't need to worry about all this now, that what are all these details. It can be learned later as well. But yeah, what we will just do, we will copy paste. First I will remove these lines, so you already have learned how to import these things. And now first thing that I'm going to do is, I'm going to import some pack modules from abc. Abc is a package, a module, and then I'm importing a class abc and an abstract method. We can go back to our previous example of encapsulation, and I can copy this here from here and bring it here. Now previously we have class student. When we are trying to say about how to set this abstraction, I want to write a class student with an abstraction. So what I will do, that I just want all of them to have this abstraction class to have this common interface across other classes that will be actually inherited from this class later. So what I will do, I will just write student, which is my class for which I'm writing this abstract class, and then I will just specify ABC, that it is inherited from the class ABC. And inheritance is something that we will just learn after a few steps once we have gone through this abstraction definition. Now here we are setting this abstract class where we have the class student inherited from ABC, which is another class that we imported. And now we have to actually specify some abstract method. And what can be an abstract method is that I will not define everything for it now. It can be defined later. For example, I will just write it as at abstract method. So you remember that from ABC module we imported ABC class and an abstract method, and here I need to specify the abstract method like this with an at sign, and it can be get details actually, not age, and I can put pass. So remember that pass is something as a placeholder. This is a abstract method that I'm not defining in my abstract class. I want every other person who actually writes a class inherited or based on this abstract class, I want him to actually specify this get detail method based on the class that he is defining. So this will be actually redefined by other classes when we write those classes. So that is an example of abstraction, and I can actually run this one. In the next step, when we actually dive into the concept of inheritance, that is where we will understand how this get detailed method was very useful. Now let's dive into the inheritance part. Because we have this code already here, so I'm just going to actually reuse it later. So we have this class defined student, which has this get details abstract method. And now in inheritance, which is actually a subclass inheriting from a superclass. So right now this student class is my superclass, and I want to write some additional classes for some different students. For example, undergrad students, grad students, I want to write classes for them as well, because I need to separate them specifically with their study levels and all these things. So let's write a class undergrad student. I will define it as class undergraduate. So undergraduate is our class, and I want it to be inherited from the abstract class that we have written as student. So in this way, this undergraduate class that we are writing will be able to access all these methods, behaviors, and attributes from the superclass, which we call as parent class, or the main class. And then this subclass or the derived class, which is undergraduate, is actually being inherited from where student. So I need to define student in the bracket. In the similar way we defined ABC here for student, I'm going to define the student as a parent class or as a super class for this undergraduate class, which is a subclass of student, or a derived class from student. So there are different names actually. So let's say we stick to one convention, that we call this student as a parent class, and undergraduate as child class, or we can stick to a convention where we call this student as a super class, and we call this undergraduate class as a subclass, which is inherited from the superclass student. Now we have defined it. The next step is to define the initialization function. One important thing that will be very important in this concept is, when you are writing an initialization function for a subclass, you will use a function called super, which is actually allowing us to do not replicate the code, do not set the features again and again that are already set in the super class or in the parent class. So name and grade, these are the features that I actually need previously. And you remember that these two features, they were already defined here in the superclass student. So what I will do now, when I'm actually saying that undergraduate is a subclass or a derived class from a superclass student, I will call this super function super. And what does this super mean? It means that it is calling the class student, which is the superclass, and it will initialize that superclass. And superclass already has this init function, and and that init function requires name and grade, which we have specified. Now in this way we do not need to set the features attributes again. Remember that previously in the init function we were setting those attributes ourselves, as self.name equal name, self.___ grade equal grade. We set those attributes ourselves in the superclass student in the initialization. But now in this derived class or subclass, we are just calling the super, which is the class student, and then we are just passing these parameters to that to initialize those attributes and set them in the super class. Now we are adding an additional attribute to this undergrad class, which is self.study level, and this one will be undergraduate. Oh, it already has done. Wait. Now, self-taught study level is undergraduate that we have set as an attribute. And we want to update the abstract method. Remember abstract method with get detail, we did not update it previously. Like it's just defined, but there is no body, just a placeholder. Now in a derived class or in a subclass, we will update this function. And how we can actually do it, we can just say return, and return will be an f string where we can actually get the name of the student, and we print that what study level it has is an undergrad student with grade. And remember how we get the grade, we actually get the grade as self dot get grade. So if you don't know about f strings, please, we have a complete video on f strings in the playlist in the description. Do watch that to know more about f strings. Coming back to this, get detail was an abstract method here that we actually wanted to define in the subclasses. And now in the subclass we have defined this get detail method where we say return f string with self dot name is an undergraduate student with grade, self dot get grade. So this is where we are calling the function self dot get grade. Now you will be worrying that you don't see the self dot get grade function defined here, right? You don't see it, but I'm calling that function. Why? Because we have the undergraduate class inherited from the student class, and student class already has this get grade and set grade methods defined. And once we have actually initialized the superclass, which is student, using the two attributes name and grade, we already have access to all those methods as well in this undergrad class, and we can actually print them. So that was an example for a inheritance based on the abstract class. We will run this one now, and we will even create a new student as an undergrad student, and I say student 3 is an undergrad student. Okay, now I will run it. Now, once we have this new student, what I can do, I can try to print the details of this student. And now the details method should print student3 dot get detail. Let's run this one. Now Abdul is an oh, I have a mistake here, is an undergrad student. Let's run this all again. Abdul is an undergraduate student with grade A. Okay, so this was the class that we inherited from the class student, and it has this get detail abstract method defined here, which we have seen. Abdul is an undergrad student with grade, and similarly you can define another class with the graduate student level as well. And let me just do that one here very quickly. So I have it written in one place, and I can just add another class. Now I just added another class with graduate student as well. So now I can just run this one again, and what I can do, I can create a student 4. Now in this graduate class that I just copy pasted here, I have done the same thing, but I just changed the name of the subclass to graduate. It is still inherited from student class, and it has a study level that is different from the undergraduate class, and it has this get detail method implemented as well. Now if we have student 4 as a graduate student, Alice. Okay, now why we get this error, I'll quickly check that. We have defined this. It's nice that we see such errors. Can't instantiate abstract class graduate with abstract method get detail. Oh, there is a mistake with S. I'll just correct this one. Let's run this again. Remember that the get detail method was actually without S, and I mistakenly just typed an S. And now I can run the student 4 again. It will work, and I can print student 4 dot get detail. Alice is a graduate student with grade A plus. So now you can see that we have two subclasses, undergraduate and graduate, which are inherited from the same abstract class student, and we have also defined these abstract methods get detail here as well. Now moving on to the last key principle, polymorphism, which actually allows ability of redefining method for subclass. So it can be that you have one method in one subclass that you want to do it differently from the parent class or from the superclass. You can do it actually. That is how we actually call it polymorphism. And for the example of polymorphism, what we will actually do is that we have this get details method that you see. That get details method has a different body that we have already seen. Over here we have get details method in the undergraduate class that is showing self taught name, who name of the student is an undergraduate student, has a very different definition inside. And then in the graduate we have it as a graduate student. So we have the same function name, but they are printing something different. That is polymorphism. That you are calling this get details function on two derived classes, and you have defined this function differently in both of them, and it's working for both of them as well. So let's take an example of this with a when we define both students, undergraduate and graduate, in a list. So I write a list here as students, and what I do, I define the first student as undergraduate student Abdul and a graduate student as Alice. Okay, now I will run this. I will create a for loop for student in students, which is my list here. Remember that list is actually enclosed by square brackets and separated by a comma. So I create one instance of object with undergraduate student and one instance of a class graduate with this graduate here. And now what I will do, I will iterate on each student in the list of students and print their detail. Now this get detail is a function that is written differently for the two subclasses, and each subclass, undergraduate and graduate, provides a different implementation of get details, allowing each object to respond uniquely to the same method call. So that is what we call the polymorphism. And now you actually have gotten enough idea of all these concepts, starting from the class definition up to the encapsulation, where you set some attributes to be private, and then we have this abstraction where we define a consistent interface of class, and then we have this inheritance where we drive subclasses from the parent classes, and which can actually share attributes from their parent or superclasses. And then we have this polymorphism where we define where same functions can have different functionality and with the same name again, and which we have seen here. So I have tried to cover this concept of object oriented programming in a basic level with this basic example, and you can build on top of this further skills by actually practicing these skills as well. If you have any questions, please comment and I will try to answer on this video. And until next time, keep learning. I'll see you in my next videos. Bye.